Hey, here's a problem we get to simplify to begin with. And for me, the best way to simplify this would be to remove the fractions, use a fraction killer. And since this is still an inequality, which obeys most of the rules of an equality, I'm going to choose to do something to one side as long as I do the exact same thing to the other side. So let's look at my common denominator, which is, or I have fours and threes. Well, if I multiply everything through this side and that side by a 12, I think my denominators vanish. So 12, that makes this a 3. So I have a 3x plus a 9, which is greater than equal to what's going on over here. That becomes a 4. That disappears. So I have a 4x minus 8 plus 1/4 times the 12 is a 3. Hey, simplified by removing the fraction. That's a win. Let's go ahead and collect terms as we go. I have a positive x over there, so I'm going to move my x's that way. And so I have an x over here. I'm going to take these terms, minus 8 and a 3 makes a negative 5. Add 5 to both sides, I get a 14. So assuming I didn't make any mistakes in my algebra, my solution set are all x's. How do you read that? All x's that are less than or equal to 14. So let's write that out. 14 is my point of interest. 14 is a solution. And I want all my x's that are less than that. And for it to be a solution, one of two ways. I can write a hard bracket right there. And then some other notation, somebody just might write a filled in circle at that particular point without that bracket. Interval notation then, I always start left to right, so it's from negative infinity. See if I can draw a negative infinity on the side. With a soft bracket. Now 14 is a solution. So we identify that by having a hard bracket. And so that's a definition, or that's a designation. When 14 is a solution, we'll use a hard bracket as opposed to a soft bracket.